Here we have a Gigabyte RTX 3090 Vision graphics card that came in for repair. We already disassembled the board, as you see right here. And let's read what the customer wrote. Want boot with card placed in PCI slot. Does not recognize card and will not let me install drivers. Card just suddenly lost power while gaming and the system shut off. Now it appears faulty. So too many issues. Won't power on, won't let him install drivers, suddenly shut off, and now appears faulty. Let's start. And by the way, those cables are the thin one, the long thin one. I do not have them in the shop here, so we're not going to be able to test the video card. We have an order from Amazon for those cables, so we can work with such cards, because anytime we get a video card like this, if the customer did not mail over those special type of cables, then we won't be able to test it. But we have an order on the way. So we're going to start by measuring the 12-volt rails, the coils here, that connects with the power connectors. We have 12 volts here, and we have 12 volts here. So I just want to quickly measure and see if we have a short on those coils, because if we do, it does not make sense to measure anything else on the board before we take care of those. Measure here, and we have 0.4 voltage drop. That's good. And measure here. Oh, we have a short. Go to ohms mode, measure, and I'm reading 0 ohms. Dead short. Okay, so we have a dead short. A dead short on one of the 12-volt rails could be a V-core Mosfet, or it could be a dead GPU. One of the two, based on my experience working on video cards. It could be one of those Mosfets here, or it could even be one of the Mosfets on the left side, right here. We have a whole set of Mosfets here, and also a whole set of Mosfets right over here. Let's remove this. So how do we figure out which Mosfet, if in fact it's a Mosfet issue, is faulty? Great question. Do we have any psychics in the room? We used to have a psychic right next door, but I guess they did not see it coming, and we ended up taking that shop after they left. And that's how we have two shops now. It used to be a psychic shop. I do not know why or how people believe in that stuff. They tell you everything that's normal. You have difficulties in your life, you have somebody sick in your family or you, stuff that we all experience. The person who's desperate will believe. The wife is calling. What did I say last time? That anytime I'm making a video, somebody has to call. Let me pause. So what we're going to do now is we're going to inject voltage at the short, at the coil, and we're going to monitor the board under a thermal camera and see if anything stands out as being hot, specifically the Mosfets, the V-core Mosfets. We did this a million times on the channel, measuring for a short using a thermal camera. So let's make it 1,000,001. Because some viewers ask, how come all you do are short circuit? I do not choose if a device has short circuit or not. Whatever we have in the shop, whatever we are working on, I pick a device at random and I record the video. If all of them have a short, then great. All of them have a short. I like shorts because I have a good success rate working with shorts, like this card here. I would rather that this card has a short circuit than something that I may not be able to figure out. So that's your answer. And I hope that every device that we get in the shop is a short circuit. So what happens if we inject voltage right here? I'm injecting 1.2 volts, and amperage being drawn by the board is 1.76. Let's see if we can see that heat on the thermal camera. Heat sometimes is very minimal because the board is multi-layer. It absorbs heat, and it makes it difficult to pinpoint where the heat is coming from. In which case, we may have to increase voltage in order to see any heat on the board. Let's go to the thermal camera. Okay, so we have a set of MOSFETs here, right there. And we also have a set of MOSFETs right over here. Okay. Apply voltage, and anything getting hot. Nothing stands out as being hot. What about this side here? I'm doing on and off on the probe so we can see if a heat spot is disappearing as soon as I pull off, and I'm not seeing that. So like I said, sometimes it's very difficult to pinpoint where heat is coming from because the board is multi-layer. The board will absorb all the heat. So let's increase voltage to 1.6. Oh no, you're gonna fry the GPU. Oh no. Don't worry about it. Relax. Okay. I think I'm starting to see something. Watch this. I just want you to pay attention to this area right here. Okay? It's a very, 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 very minimal white spot. It's not even a yellow spot or red spot, but watch this. See it? Right over here. One more time. Let's do this from another angle. Yeah, now it's more visible. Watch this. Right there. From another angle, I'm able to see it. Look at this. Right here. Where's the bad guy? I'm going to put an X on it. Right here. That's the component that has the slight heat on it. That's probably the faulty component. If you look at the component before I put the scratches, there's no way you would have been able to find out or figure out that this is the problematic component. Very difficult. Unless you start pulling those MOSFETs up one by one to figure out where the short is coming from. But you have a whole list of MOSFETs on the right, and you have a whole set on the left. Good luck. If you have the time, good luck. Let's remove the MOSFET, and we have to be careful because we have aluminum capacitors right on the right side, and those capacitors do not like heat. They will pop. So I have a large heatsink. We can put the silicon pads, the pre-cut silicon pads also. But since I have this one here, why not? How come you're not using the pre-cut silicon pads? I can. That's what I have available on the bench right now. And let's do it. The board is very thick. And the board is going to absorb a lot of the heat that we are putting on it right now. The board itself must reach the melting temperature of solder in order to be able to desolder this component. Like this. Great. Out. Let's go ahead and measure and see if we still have a short. Do we still have a short? That's the question. The answer is the short is gone. You see why I love devices with short circuit? Look at this. The short is gone. If we measure in ohms mode, what readings are we getting? Right now it's 78K. The board is still hot, so the reading may not be accurate, but it's not in the ohms anymore. It's in the kilo ohms. Diode mode, one more time. 0.3 voltage drop. It's gonna probably rise up to 0.4 after the board cools down a bit. 0.314, 316, 317. It's gonna go up to about 0.4, 0.47. We did it. We did it. All we have to do is replace the component, and we're gonna wait to get the cables from Amazon so we can test the video card. Another 3090 saved, most likely, unless we have issues elsewhere. But there's a very good chance that we fix the card. The area is very tight, very narrow, so it's like a mountain on the right, a mountain on the left, and you have to work in the center. Okay, the pads on the left are meant to bridge. They're all one pad. But I try not to bridge them so we can save the world from complaints. That's enough. That's enough. That's a lot. And that's enough. Alright, so we should be able to solder the DR MOS. We have enough solder everywhere. And a lot of those pads are connecting to each other. Okay, so I have a replacement Mosfet right over here. I just burned like half of the hair on my finger, but that's okay. And I can smell it. Look at how much heat it takes to solder that MOSFET, that DR MOS. Now we're gonna press it down. Nice. Nice. I can hear somebody saying, oh no, it's not nice. Look at the overflow on the left. Are you serious, bro? You think we're gonna leave it like this? You see how we do it? Who's we? Some people ask. Who's we? We is I. But I do not like the word I. I did this, I did that, I gave him this, I gave him that. I'm the one who did this. I is a very ugly word. So we is a lot better. Awesome. We did an awesome job. We do not need to remove the bridge on the top here because all those pins are connecting anyway. And since this is not an archo, we do not need to do more work than we have to. So let's take a look at the MOSFET that we soldered so I can show you what's going on. This end will be here and the bottom end should be on top when the chip is flipped. You can tell that pin number 1, 2, 3, and 4 are the same pad. They should bridge. It's okay for them to bridge. And then pin number 1, 2, and 3, they bridge. And all the pins on the top, they are connecting as one. Okay, so it's okay for those to bridge. It's okay for those to bridge. Okay for those to bridge. Okay for those to bridge. And you can tell on the bottom we do not have any bridges. We should not have any bridges on the bottom. I just wanted to show you this so you can gain more knowledge and you know why it's okay for some pins to bridge. Right now I just wish that we can test the card so we can finish the video with a good positive outcome, but like I said, unfortunately I do not have the cables to test it. We do have the cables on order. Maybe I'll update the video with a comment. I'll pin the comment. Before we end the video, let me just go over the calls again, make sure that we do not have a short. Meter in diode mode, 0.426. Okay, I told you it's gonna go up to around 0.45, 0.47. Look at this, 0.430. Perfect, perfect. All right, that's it. We can end the video right here. I hope you enjoyed it. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.